Hi everyone and welcome back to another Blender tutorial. In today's video I'm going to show you how to properly animate the movement of a tracked armored vehicle, especially how to get a realistic motion for a tank. Now, unlike animating a regular car where the wheels simply rotate in a circular motion, animating a tank is a bit more complex. This is because tanks use tracks and sprockets, not just wheels. You need to ensure that everything moves in perfect synchronization. That includes the sprockets, the tracks, the road wheels, return rollers, and even how the track interacts with the ground. Another key factor is slipping. We want to avoid any mismatch between the movement of the tracks and the tank's actual motion. If the track is slipping or out of sync, it breaks the realism. So in this tutorial, I'll walk you through how to animate all these components together cleanly and correctly for a realistic tank movement. Alright, without further ado, let's jump straight into the tutorial. First, I'll press the slash key on my numpad to isolate the object I want to work on. Then I'll hit Shift A to add a cube. Now this is where we'll do a tiny bit of modeling. Don't stress if you are new to it. Next, I'll go into edit mode and turn on X-ray view so we can see through the mesh. Now, we are going to shape in this cube to become a piece of the track that wraps around the wheel. I'll switch to top view and start positioning a piece properly. I'll move it into place by shifting it along the X or Y axis, depending on the tank's layout. These will form the individual pieces for the track mat of our tank. With the base shapes in place, it's time to give them a little bit more character. I'm going to remodel them slightly to make them look like natural tank track links. First, I'll go into Edge Selection mode, then Shift-click to select all the edges around the object. Next, I'll press Ctrl B to bevel the edges and scroll up with the mouse wheel to add some smoothness to the curve. You don't want to go overboard here, just enough to soften those edges and give it that solid tank link feel. Now press Alt Q to enter Edit mode on the second object and repeat the same process. Select all the edges, then Ctrl plus B again to bevel, and boom, nice and smooth. Next, I'm going to add an array modifier to both of the track objects. So I'll head over to the modifier tab, click on add modifier and choose array. That instantly gives us a second instance of the object to work with. Now I will adjust the offsets to position it correctly so the pieces align seamlessly, just like a real tank track links. Take your time here to get the spacing just right. It is important that each piece sits perfectly next to each other with no overlap or gaps. This makes sure the track looks solid and moves smoothly when we animate it. Alright, now I'm going to add an array modifier to the second object as well. Just like before, head over to the modifier tab, click on add modifier and choose array. Now that's in place, I'll adjust the position so it sits right at the center, perfectly aligned with the rest of the track layout. Again, getting this placement just right is key. It ensures everything fits together seamlessly when we duplicate it around the wheels later on. There are a few different approaches we can take from here, but I'm going to go with one that is beginner friendly. First, let's apply the array modifier to both track objects. This locks in the changes we've made so far. Next, I'll select both objects and group them into a new collection. I'll name this collection Mat1. This will serve as our original set. Now I'll duplicate that collection and rename the duplicate to Mat2. The idea here is to keep our original untouched in case we need to reference or use it later. I'll go ahead and hide the original and work with the duplicate from here. Now I'm going to join the two track objects together into a single mesh. This will make it easier to work with. Then I'll add an array modifier, but this time we are using it to extend the track in the y-axis. Let's try adjusting the offset to around 0.75 to get the right spacing between the rows. Once that's in place, we can go ahead to increase the number of columns to build up the full shape of the track mat. Alright, at this point, I'm heading back to the main scene. I'll go ahead and hide those objects we are not going to work with, just to keep things clean. Next, I'm going to add a curve, especially a path. This path will be what our track follows when we animate it. Once the path is added, I'll position it right at the center where our track object is located. This is important because the path will control the direction and motion of the track as it moves around the wheel. Now I will go into edit mode and start shaping the path. Using the E key, I can extrude new points and guide the curve to follow the layout of the wheel. Basically, I'm building a path that flows naturally around the track layer, and this is what we will use to animate the movement. Now, as we reach the end of the curve, you'll notice that the first and last vertices are really close to each other. To close the loop and make it seamless, I'm going to select both of those vertices, press S to scale, and then 0 to lock them in together perfectly in the same spot. And just like that, we've got ourselves a complete track path ready to animate. Alright, now it's time to wrap our track around the curve we just created. To do that, we'll use the curve modifier on our track mat. First thing first, we need to make sure that the origin is set correctly. With the track object selected, I'll go to the object menu, then set origin and choose origin to center of mass. Now, I'll head over to the modifier tab, click add modifier and choose curve. Then, I'll use the eyedropper tool to select the curve path we created earlier. Now, here's the thing. You might notice some weird deformation happening to your track. This usually happens when the object's position doesn't match that of the curve. To fix that, I'll simply copy the location on the X, Y, and Z of either of the objects and paste on the other. For this, I'll copy that of the path we created and paste it on our track object. And now the track now wraps cleanly around the curve. Now here's the issue we're facing. When we increase the array modifier count, you'll notice that right at the point where we join those two vertices together, the track doesn't follow through cleanly. But instead of continuing around the curve, it jumps upwards, creating a break in the flow. That's clearly not what we want, and it's a common issue when working with curves and array modifiers. But don't worry, this is an easy fix. Alright, so to fix this issue, the first step is to identify exactly where the glitch is happening. In this case, it is right here where the paths join back together. So I'll select the path, go into edit mode, and highlight the two vertices causing the problem. Now I'll press Y to separate them. Next, I'll check the track. When I move it along the curve now, it moves, but it drifts away from the path. So what's the fix? I'll go back to the path, enter edit mode, select all the vertices with A, and then hit Alt C to toggle cyclic. That reconnects the path in a proper loop. Once that's done, I'll switch back to object mode, select the track again, and now when I move it, it follows the path perfectly. Now I can extend the array to get a fully wrapped tank track around the wheel, just like we want it. And just like that, we are done modeling the tank wheel for our build. From here, I can go ahead and press the slash key on my numpad to exit isolation mode. To maintain order in our workspace, I'll continue by renaming all objects in our scene. I'll add an empty and select the sphere. Now I'll add a transformation constraint, but first I'll select all the wheel objects and parent them to the curve path we created earlier. Then I'll select the curve path and parent it to the hull of the tank. I'll select the wheel of our tank and add a constraint. I'll head over to the constraint tab and use the transformation constraint. I'll select the target as the sphere we created. I'll quickly rename it to sphere. Next, I'll click on extrapolate, change the owner to local space, set map from to rotation and map to location. I'll change the y max value to 2 and set the y source value to minus 0.05. So now each time I rotate the sphere in the y direction, the track rotates as well. So I'll go ahead and set the same constraint for the sprocket. I'm going to add a transformation constraint to the sprocket. I'll select the sphere as the target. Then click on extrapolate. I'll set map from to rotation and map to rotation. I'll change the owner to local space. Now I'll change the y max to 2 degrees. I'll change the x max to 9.2. I'll change the x source axis from x to y. Now when I rotate the sphere in the y direction, the sprocket rotates as well. This number works for me. You might get the figure wrong on the first try, and you will notice that one of the objects will be faster than the other. If that happens, just go back and adjust the values until you get the right sync. For me, it's 9.2. To help you understand how the transformation constraint works, I will rotate the sprocket in the y or z direction. The motion isn't what we want. Instead, we want it to rotate along the x-axis. So I'll add a transformation constraint on the sprocket. The target will be the object we want to drive the motion, in this case the sphere. I'll enable extrapolate and change the owner to local space. We want the sprocket to rotate when the sphere rotates, so I'll set map from to rotation and map to rotation. Let's say when the sphere rotates 2 degrees on its y-axis, we want the sprocket to rotate 10 degrees on its x-axis. I'll put those values accordingly. Now if I rotate the sphere, nothing happens yet because the driver isn't connected yet. Since the sphere is rotating in the y-axis, we need to assign the y-axis as the source. Once we do that, rotating the sphere on the y-axis will drive the sprockets to rotate along the x-axis. And that's how transformation constraints works. Select the sphere and add a transformation constraint. The target is going to be the hull of the tank. I'll select extrapolate, change the owner to local space. For this, I'll set map from to location and map to rotation. I'll give the y max a value of 2 and the y source a value of -80. Now, each time I move the tank, the wheels rotate. So I'm going to add another transformation constraint to the sphere. This time, I'll choose the hull as the target. I'll select extrapolate, change the owner to local space, just like we did before. For this, I'll use rotation for map from and rotation for map to. I'll set 1 degree for the z max and change the y max in map to -1.53. I'll also change the y source axis to z. So now each time I rotate the hull, the wheel of the tank moves. Alright, so now I'm going to add the last transformation constraints to our sphere. As usual, I'll choose the hull as the target. I'll select extrapolate and change the owner to local space. I will leave the map from as location and change the map to rotation. I'll give the x max a value of 2, and for the map to y max, I'll set this to a value of -8. I'll change the y source axis to x. So now each time we move the body of the tank in the x and y direction, the tracks start moving as well. I know transformation constraints might be difficult to understand at first, but as you keep playing around with the transformation constraints, you get to understand how exactly it works. At this point, what is left for us to do is to duplicate the wheel object to the other end of the tank. I'll copy all the wheel objects. I'll change the pivot points to 3D cursor. Then I'll duplicate this object using Shift plus D, press X, X, and -1. Now, I've successfully duplicated the object to the other side of the tank. Now I'll place all these objects into a new collection. Let's call this wheel 2. Now when we move the hull, we can see that the duplicated wheel has some mismatch compared to the original wheel. This is because Blender performed some calculation on our constraints while referencing them to the original objects. So for that reason, we have a little error in the duplicated wheel. To fix this, I'll add a new empty and choose sphere. With the sphere selected, I'll select the second sphere, head over to Object, click on Constraint, and copy constraint to the new sphere. I'll go ahead and delete the old sphere. What we are trying to achieve here is add all constraints from the old sphere to the new one. I'll connect the targets of our constraints for the wheel and the sprocket to our new sphere. Now when we move the hull, the wheel and the sprocket moves correctly for the duplicated parts of our wheel. To add the constraint to the ruler of our tank, I'll select all of them, and the last object to be selected should be the object with the constraint. Then head over to Object, Constraint, and I'll copy constraint. I'll do the same for the other side as well. And there you have it, a properly rigged armored vehicle ready to be animated. With all the constraints in place and everything moving in sync, you are now set to bring your tank to life with realistic animations in Blender. If you found this tutorial helpful, don't forget to like, subscribe, and turn on notifications so you don't miss any future tutorial. Thanks for watching and see you next time.